part one of the video, I show how to use Sagebox at a Hello World level by building a Sierpinski Hello World program that uses Sagebox at a very simple beginning level. In part two of the video is when I build the Sierpinski Triangle to show the program that we showed in the introduction. So let's start with a blank program here. The Sierpinski Triangle, as it turns out, is a really good Hello World program for GUIs because we're just really drawing a triangle. Right? And then so later what we do is we add the nice gradient and the nice text in the input box. But for now, let's just start with a plain Hello World program and then turn it into a Sagebox Hello World program where we bring up a graphical window and then put things out to that window. So as you can see, I just wrote a Hello World program for C++. And then let me go ahead and write a Hello World program for kind of a canonical C++, just showing that, we can take any flavor that we want to take. And then I'm going to convert this into a Sagebox Hello World program. And so instead of including standard I/O or I/O stream, we include Sagebox.h because it includes all of those anyway. So now what we have to do is call Sagebox new window to create a default window of about 1200 by 800 pixels. We can give a new window a number of parameters to affect the window size, shape, color, a whole bunch of things. But if we don't, it just creates a default window for us and places it automatically. So now I'm going to copy the printf statement and then add win.printf so it'll print the message out to the window that we just created instead of the console window. So now when I run this program, you'll see, if you look very closely, you'll see a blue flash before the program ends. Let me run that again in slow motion. So what you'll see is a window with a blue background come up very quickly and then disappear right before the program ends. So what's happening here is that the program is ending and it's closing down any open windows or GUI windows that are created in the system. We see the leftover from the console window, but we need to stop the exit so that we can dismiss the window when we want to dismiss it instead of the program just ending on us. One of the things that you see a lot in Sagebox program examples is a call to Sagebox exit button. And what this does, it brings up a window letting you know the program is over with an OK button so it can stop the window from closing until you're ready to close it by pressing the OK button. There are many other ways to do it, and this is just one example. So now we can see the output to the console window, and we can also see the output to the graphical window we just created. But we really want to do more interesting things than just print out small text. So let's make a bigger font here using the keywords that we can use in the write function and other functions. In Sagebox, we use the namespace KW for keyword namespace to use all the keywords we want for various functions. So we can change printf to write. We can still use printf, it's just easier to use write. We can use write and add some keywords such as a font and other keywords. So in this case, we're going to use a 100-point font. We could express it as arrow 100 or Times Roman 100, whatever we want, or we can just express it as numerical 100. And then when we run it, we get a much nicer, bigger font in our graphical window. We can also string together keywords, for example, with a just center or just a center here. And when I run it, you can see it's now in the center of the page. And then we can also add, say, an angle, so an angle 45. When I run that, you can see that it actually makes the text at an angle 45 degrees. In C++, we can put using namespace KW either as a global here or inside of a function to make it more local so that we don't have to use KW : in front of everything, which makes the keywords look kind of like a more traditional keywords from, say, a scripting language. And as you can see, when I run it, it runs exactly the same. But I'm going to put the KWs back because I like the KWs personally because it makes the code more self-documenting and more easily understood from a kind of top-level view. We can also use curly braces inside the text to tell the text what to do to make things a little easier. So let's get rid of the angle, and then let's also get rid of the font here and put in the font in curly braces. So if we put in curly braces a number, it tells us what font we want to use instead of using KW font. So when we run it, we get exactly the same thing. We just use the curly braces to specify the font instead of KW font. We can also add colors, such as cyan here. And if we look at the checked-in program, the one that we're building, you can see the two top lines have two different fonts and two different colors. And this is done in the same write line by combining these directives together. So let's change this current line. Let's keep the 100-point font, say Sagebox Hello World. But on a new line, let's put a 25-point font and a cyan color and just put in parentheses when we're using a window. Since we don't need to use a window with Sagebox, it's just one of the options that we have. So now when I run it, we have a nicely formatted message centered in the window using two different fonts, a 100-point font and a 25-point font, and two different colors just by using the curly brace directives inside of the write statement. As I mentioned, the Sierpinski Triangle program is kind of a hello world of GUI programming because we're really just drawing triangles. We add all the other stuff later. So let's go ahead and do the first part of the Sierpinski program and draw a triangle. Since we created the default window, we know the center is at 600, 400 since the default size is 1200 by 800. We can also use get window center to get the window center, and I'm going to do that later. But right now, I just want to create an arbitrary triangle kind of centered about the center of the window. And to do that, I'm just going to add 3 arbitrary points. Drawing a triangle is pretty easy. We just call draw triangle with A, B, and C are points and a color. In this case, a string. But we can also use a pan color, which is a Pantone color, or we can also use a sage color, which tend to stick to primaries as opposed to Pantone colors. And then when we run it, you can see a triangle in the middle of the window with a border size of 1 pixel. We can also use the pen size keyword to set the border size to 20. So now when I run it, we have a much thicker triangle. We can also change draw triangle to fill triangle. And then also, in which case we don't need pen size, I'm also going to show using a symbolic color. I'm going to use pan color yellow instead of the string just to see the difference on that. And now when I run it, we have a filled yellow triangle in the middle of our window. Now on this right, I'm a 70, just at 70 pixels, just eyeballing it really. But I'm going to use center X instead of center, and that's going to center it horizontally at wherever it is vertically, so I don't have to worry about putting in the X coordinate there. That's why it's 0. And so I'm going to do that, and then I'm going to add about 75 pixels maybe to all these points, and then when I run it, we have this kind of nicely framed Hello World program with a triangle. So that's a basic introduction to using Sagebox with the Sierpinski Triangle as a context for kind of a Hello World program. In the next video, I show how we use graphics and controls and build the Sierpinski Triangle.